Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, finding the equation of a circle. Now I'm going to do something different with today's video. Because we're going to have a few different parts, I'm going to put time codes for each of the sections I'm going to cover in the description box below. So if you feel like you already know a certain section, or if you just want to skip to the end where our question of the day is waiting, feel free to visit the description box and click on the relevant time codes. As always, if you have any questions, feel free to put them in the comment box below. And if you have a question about your own homework, feel free to visit me on Facebook at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, without further ado, let's talk a little bit more about finding the equation of a circle. So the first thing we're going to talk about is the actual equation we're going to be looking at. And that is going to be, so this is going to be the equation of a circle that we're going to be using for this video. And this is something we call in standard form. So this is the standard form of your equation of a circle. Now you might be looking at all of this and wondering, what are all these letters for? What do they mean? Well, let's talk about the components of the circle. And that's going to help us identify what this is and maybe a little bit more when we're talking about the circle. So the first component we're going to be discussing is the radius. Now the radius of a circle is going to be the distance from the center, I'll denote that with a C, to any point on the circle. This is called the radius. The center to the point, the distance between them is the radius and is denoted with an R. So the next component of a circle that we're going to talk about is the diameter. Now diameter is pretty related to the radius in that instead of being from the center to any point on the circle, we're going to go from one point of the circle to another point on the circle. So I'm going to call this one P, I'm going to call this one Q, and this one's going to be called S. So the diameter of a circle is going to be from point Q to point S, passing through the center. So you have to pass through the center, and it's going to be the distance from those 2 points. So from Q to S, passing through the center, this distance is going to be called D for diameter. So the radius was denoted by an R. The D is what we use to denote the diameter. And once again, distance from one point of the circle to another point, passing through the center. So you can't have a distance from this point to this point be the diameter. That's not the diameter. You have to pass through the center. Remember, you have to pass through the center for the diameter, but it's the total length from one end of the circle to the other end of the circle, whereas the radius goes from the center to any point on the circle. So you might have noticed that there's a relationship between the radius and the diameter. If the diameter has to go through the center and the radius is from the center to a point, then you see that they both hit the center at one point in time. But notice for a circle, if this is the radius, well, if you extend that, this whole thing becomes the diameter, which means that the diameter is going to be twice the radius, or the radius is going to be half the diameter. The radius is going to be the diameter over 2, and the diameter is going to be radius times 2. So we've talked about the radius and we talked about diameter. When we look back at this equation, you see that we have this R here. Well, that R is going to be this very radius that we're talking about. So there will be a lot of times where they might give you the diameter, and if you're trying to find your equation, you're going to need to make it into a radius. Now that we know the diameter is going to be 2 times the radius, we can always divide our diameter by 2 and get our radius. So that's why we want to know what a diameter is and what the radius is. So the last thing we haven't talked about is this H and this K. Well, that's going to be what we denote as the center of a circle. If this is your center of your circle, we denote that point here. You see we're on this graph here. We denote this point as 2, 3, where X is 2 and Y is 3. So this is the X-axis, this is the Y-axis, and our point here is going to be 2, 3, our center point of our circle. So this h and this k, in this case, h is going to be 2 and k is going to be 3. H and k, when we write it this way, is called the center of the circle. And that's going to be very necessary when you're trying to find this equation of a circle. Because you see here, we do x minus whatever the x value is for our center, right? So in this case, it was 2. And then we do y minus whatever the y value of our center is. In this case, it would be 3. So if we were to plug this into our equation, we would get something like this. Now, we don't have any r's here. We're not really worried about that just now, but I just want to show you how we plug it in, and this is going to be the left side of your equation when you plug in your h and your k. So if you have your standard form written like this with an h and a k, that h and a k is just going to be your center of your circle. So as long as you know what your center is, in this case 2, 3, you can plug it into your equation and you can set up half of your equation. The next thing you have to do is find your radius. So let's talk about how to find that radius. So let's say we have this circle here and we're trying to find the radius, right? So we have our center at 1, 1, and we have a point on our circle being 2, 3. In order to find the radius or the distance from here to here, we're going to use something that you might be familiar with called the distance formula. If you've ever seen the distance formula, we take our x that we're trying to go to minus our x that we're leaving, and then we square it. We take our y that we're trying to go to minus our y that we're leaving, and then we square that, and then we sum those two together, and then find the square root of that, and that's our distance. But do you see, this is going to be a point on the graph, and this is going to be another point, and the radius is just the distance between those two. So this is really just the radius. And in this case, our x2 is going to be our point on the circle, so we can substitute that with our 2 here. And our x1 is going to be our center point, so we can substitute that with a 1 here. Our y2 is going to be this point on the circle, so we can substitute that with our 3. And our y1 is going to be our center, substitute that with a 1. So we're going to be using our distance formula to find what the radius is. So when we do all this, we get the square root of 2 minus 1, which is 1 squared, plus 3 minus 1, which is 2 squared. And then we get the square root of, what's 1 squared plus 2 squared? That's going to be 5, right? 1 plus 4 gives us 5. So r is going to be, in this case, the square root of 5. So this is how we find our radius. Using our distance formula, we can find our radius as long as we have our 2 points, our center and whatever point we're looking at on our circle. Here's a cool tip for you. Since we're already talking about the distance formula, let me show you how we can use our distance formula to derive our standard form of our equation of a circle. So let's say we have this circle here. And we already talked about how the radius can be found by using the distance formula. So let's set this up. So we have our radius equal to the square root of, and we said it was supposed to be x2 minus x1. So let's just write that out just to kind of stay consistent, plus y2 minus y1 squared. So we have our distance formula, and instead of a d here, because we don't want to get confused with diameter, we're going to put our r for radius, right? Now, what's our x2 and our x1? So in this example here, our x2 is going to be the point on the circle that we're going to be going to. So we're going to say that's going to be just x, right? And then our x1 is going to be this h here. So we're going to square that. And the same thing for our y. So our y2 is just going to be y here. And our y1 is going to be this k. And we're going to square that. And we have our radius. Now this might look pretty familiar to our standard form. If you recall, our standard form was something like, so what's the difference between this and this? This is our standard form of our equation of a circle, and this is our distance formula that we use to find r. Well, the only difference is we square both sides. So if we square this That becomes r squared, and we square this and we lose the square root. So we get r squared equals x minus h squared plus y minus k squared, which is exactly what we have here. So you see, you can actually use your distance formula to derive your standard form of your equation of a circle, and you don't have to remember what this actually is anymore. As long as you can get from this step to this step here, you can always figure out or derive what your standard form is supposed to look like. Don't worry about trying to remember it if you can't. Just figure out how to go from point A to point B, and you can always derive it. So we talked about the equation of a circle in standard form. We talked about these circle components that are going to be necessary. We also talked about how to find the radius and how you can derive our standard form of our equation from the distance formula. Now we're going to put all that together and tackle our question for today. So as you see, it says we need to write an equation for a circle if the endpoints of a diameter are 1, 1, and 1, negative 1. So remember, we said the diameter is going to be from one point to the other side of a circle, but we have to pass the center. So one point to the other point, but we have to pass the center. So this is saying we're going to go from 1, 1 to 1, negative 9. So I'm going to put 1, 1 here, and then I'm going to put 1, negative 9 here. And remember, we also talked about how the diameter is going to be 2 times the radius. So we know if we can find a diameter, we can simply just divide it by 2, and then we can find our radius. So this is what we're trying to get. We have to find our diameter first, and then we can find our radius. So to give us the 2 points for our diameter. So let's find our diameter using our distance formula. So this time I'm going to put d for our diameter, and then we're going to do our x2, which is going to be this 1 here, minus our x1, which is going to be this 1 here, squared, plus our y2, which is going to be that 1, minus is going to be a negative 9. So minus a negative 9, I'm going to put that negative 9 in parentheses here, squared. So that's our distance formula. This d is for diameter this time. So we're going to simplify this. What's 1 minus 1? Well, that's just going to be 0. And 0 squared is just going to give us a 0 again. So we're just going to focus on this. So what's 1 minus a negative 9? Well, that negative negative makes this a positive. So it's really just 1 plus 9. And 1 plus 9 squared is going to be what? Well, this is going to be square root of 100. And what's the square root of 100? Well, that's just going to be 10. Now, you could have gone from this step straight here because this square root will cancel out that square, but I just wanted to make sure you knew how we got from this point to this point. So we know our diameter is going to be 10. So if our diameter is 10, we know our radius is going to have to be 5. So we know our radius is 5. So we know half of our equation now. Now we have to find this c. What is our center point? And remember, we denoted that with an HK. So what is our center point for this equation? Well, if we go back to the diameter here, going from this point to this point, we want a distance of 10, right? So if we were to go from this point to the center, that would give us a distance of 5. I want you to notice one thing about this. Going from here to here, our x value didn't actually change. So the whole distance of 10 came from our y differences. From negative 9 to 1, that was a distance of 10. The x didn't change. Well, if we stay along this same line, we can use that for our radius as well, right? Our x shouldn't change. So that means instead of going a distance of 10 to get from negative 9 to 1, we can go a distance of 5. So this is going to be 1, and what's 5 up from here going towards 1? Well, that's going to be negative 4, right? If you start at negative 9 and you add 5, you're going to get a negative 4. So we realize our 1 didn't change. Our x value didn't change. The only thing that was changing in this question was our y value. So we can simply add our radius to our y value that we're leaving. And that will give us our y value of the center because this is going to be a distance of 5. So in this case, our center is going to be 1, -4. So now that we have our radius and we have our center, let's find our standard form of our equation of a circle. So writing it out, we have x minus h squared plus y minus k squared equals r squared. So we know x doesn't change here. H is going to be 1 in this case. Y doesn't change. And this k is actually supposed to be negative. So this is going to be a minus a -4. So we're going to say plus 4. And what's our r? Well, r is going to be 5. And we're going to square that. So if you rewrite this, you can somewhat write it this way, but some people might want you to square that. So we can rewrite this as x minus 1 squared plus y plus 4 squared equals 25. So either of these two could work. Some people might want you to square that out. So this is what I would consider our final answer. X minus 1 squared plus y plus 4 squared equals 25. So do we have that as an answer for our question for today? Yes, this is going to be B, right? B, if you look up here, is x minus 1 squared, y plus 4 squared, and we're going to add those, and it equals 25. Don't fall into the trick. This is 5 squared, not just 5. We don't want to just forget our squared here. That's always going to be squared for this equation of a circle. So I hope you're able to follow in today's example, and I hope that the time codes were helpful to navigate this video a little bit better. As always, if you have any questions, feel free to put them in the comment box below and tell me what you thought about the time codes and if you want to see these on more of my videos. If you have a question about your own homework like you see on this channel, remember you can visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.